Question number 7. We have to show that y equal to log of 1 plus x minus 2x by 2 plus x and x greater than minus 1 is an increasing function of x throughout its domain. We will find the derivative of this function. Differentiating both sides with respect to x, we have dy by dx, and log, when we differentiate, we get 1 by x, and in place of x we have 1 plus x into derivative of this 1 plus x is 1 is 0 and x is 1. This is in a separate bracket. And here we will use u by v method because both numerator and denominator we have the variable, and the formula will be denominator into derivative of numerator, that is 2, minus numerator into derivative of denominator, that is 1, by denominator the whole square. Okay, now we have 1 by 1 plus x minus 2 2s are 4. Just write in the bracket as we have minus outside. So 4 plus 2x minus 2x by 2 plus x the whole square. Plus 2x minus 2 is cancelled. We have 4 by 2 plus x the whole square. Taking the LCM, we will get 2 plus x the whole square or x plus 2 the whole square. In between minus 4 we have into 1 plus x by 1 plus x into 2 plus x the whole square. Now expand and try to simplify. So here it will be a plus b the whole square. So we have 4 plus x square plus 4x minus 4x by 1 plus x into 2 plus x the whole square. If you check, plus 4x minus 4x gets cancelled, plus 4 minus 4 gets cancelled. So we have x square by 1 plus x into 2 plus x the whole square. This is the simplified form of the first derivative dy by dx. We have x square and 2 plus x the whole square. Since those are square, we can write it as greater than 0. Okay, only if x is greater than minus 1, we have this 1 plus x greater than 0, because taking 1 to the right side, we have minus 1, so x greater than minus 1. So therefore, we get this dy by dx greater than 0 if x is greater than minus 1. So the function is increasing throughout the domain of the given function. Question number 8, we need to find the values of x for which the given function is an increasing function. Okay, as usual, we'll find the derivative. So dy by dx equal to d by dx of, we'll simplify here. So this will be x square, this will be x minus 2 the whole square. So when you multiply inside, after expanding this as a whole square, x square into x square minus 4x plus 4. Either you can use UV method or you can multiply and you can differentiate. So we get x square into x square, it is x power 4 minus 4x cube plus 4x square. Now we'll differentiate. We'll get 4x cube minus 12x square plus 8x. This is the first derivative. When we equate this to 0 to find the x value, we get, overall we can take 4 as common and x as common. So 4x into x square minus 3x plus 2 equal to 0. So we have 4x equal to 0 and this term x square minus 3x plus 2 equal to 0. So when we factorize this, we get 4x into x minus 2 into x minus 1. So we have 4x equal to 0, x is equal to 0 by 4, we have 0. X minus 2 equal to 0, we'll get x is equal to 2. X minus 1 equal to 0, we'll get x is equal to 1. When you put on a number line, minus infinity to plus infinity, we want the x values as 0, 1, 2. 0, 1, 2. So we have the interval minus infinity comma 0, 0 comma 1 and 1 comma 2, 2 comma infinity. These are the open intervals for the given function. Now we will check the signs of those. For minus infinity comma 0, all the x values will be negative. And we have the derivative, the simplified form as 4x into x minus 2 into x minus 1. So we get negative, x value as negative, and negative minus negative will get negative, and negative minus negative we get negative. So negative into negative, positive into negative, negative. So this is less than 0, which means the function is decreasing or strictly decreasing. Then when x belongs to the interval 0, 1, x values are lesser than 1 but greater than 0. So we get y dash is equal to, so this will be positive. Anyway, x values are positive. as it is from 0 to 1. So this will be positive. X minus 2. As the values are lesser than 2, smaller number is positive, greater number is negative, we'll get the negative sign. And since it is less than 1, 1 is greater and values are less than 1. So small number positive, greater number is negative. So we get negative sign. Negative into negative positive, positive into positive, positive. That means the first derivative is greater than 0, function is increasing. And when x belongs to the interval 1, 2, x values are positive, greater than 1 but lesser than 2. So the signs will be, for x it will be positive. Yeah, so since it is greater than 1, and here since it is lesser than 2, 2 is the greater number, x is smaller. Smaller number is positive, greater number is negative. We'll get the negative sign. Since it is greater than 1, smaller number is negative, greater number is positive. So we get positive sign. Positive into negative, negative, negative into positive, negative. We get the derivative as less than 0. That means function is decreasing. Next, when x belongs to the interval 2, infinity. That means all the x values are greater than 2. That means all the values are positive. And when you check with the sign, positive. Smaller numbers are 2 and 1 with negative sign. Greater numbers are x with positive sign. We get positive. So positive into positive into positive. Everything is positive. So we get the sign as positive. That is y dash is greater than 0. The function is increasing. So we get for increasing, the intervals will be 0, 1 and 2, infinity. As the question is to find for which values we get the increasing function, we get 0, 1 union 2, infinity. This is the range we get the function as increasing. Question number 9. We have to prove that this function y is equal to 4 plus sin theta minus 2 plus cos theta minus theta is an increasing function of theta in the interval 0, by b2, the closed interval. Okay. As usual, we'll differentiate with respect to theta here. We'll follow the u by v method. So 2 plus cos theta into derivative of numerator will be 4 cos theta minus 4 sin theta into derivative of denominator is minus sin theta, the whole by 2 plus cos theta the whole square minus, here it is 1. We'll take the LCM. We'll multiply here. 2 4s are 8 cos theta and here it is 4 cos square theta minus into minus plus 4 sin square theta. When we take the LCM, it is, we'll expand inside. 1 into 2 plus cos theta the whole square will get the same. 4 plus cos square theta plus 4 cos theta the whole by 2 plus cos theta the whole square. We are taking 4 as common. So for these two terms alone, so cos square theta plus sin square theta identity is 1. 4 into 1 is 4. 8 cos theta plus 4. Taking minus inside, all 3 are positive, so you get all 3 as negative. Minus 4 minus cos square theta minus 4 cos theta the whole by 2 plus cos theta the whole square. Plus 4 minus 4 gets cancelled. 8 cos theta minus 4 cos theta is 4 cos theta minus cos square theta by 2 plus cos theta the whole square. We can take cos theta as common. So we get 4 minus cos theta by 2 plus cos theta the whole square. If you check with the sign for this given interval 0 to 90, so everything is in terms of cos, isn't it? Remember the graph we did earlier. 0, 1, minus 1, pi by 2, pi, 3 pi by 2, 2 pi, etc. Cos 0 is 1, cos 90 is 0, then cos 180 is minus 1, then again cos 270 is 0, it goes on. For us, the given interval is 0 to pi by 2. The curve is above the origin, so function is increasing. So cos theta, it is, since it is closed interval, cos 90 is 0. We get the chance of 0, isn't it? So it is greater than or equal to 0. 4 minus cos theta, if you check, cos theta's value is only within the range of 0 to 1, not exceeding that. So it is less than 4, greater number is 4, smaller number is cos theta values. So anyway, we'll get positive value, but we don't get 0 here. So this is greater than 0. And 2 plus cos theta again, cos theta's value is from 0 to 1. Anyway, the whole square will get the positive value and we don't get any zeros here. So it is greater than 0. But the product we get as greater than or equal to 0. The whole thing is greater than or equal to 0 as all the 3 separate terms we have discussed. Since the derivative is greater than or equal to 0, the function is increasing in the interval 0, pi by 2. Question number 10, we have to prove that the logarithmic function is strictly increasing on the interval 0, infinity. So the function is log x. When we differentiate, we get as 1 by x. The domain of logarithmic function is 0, infinity, and these 0 and infinity values not included within that range. So definitely 1 by any number we are going to get the positive, because both numerator and denominator are positive. So we get as greater than 0, we will not get 0 value. So there is no chance of getting 0 here, as we get the open interval of 0, infinity. So the function is strictly increasing on the interval 0, infinity. Then question number 11, f of x, they have given x square minus x plus 1. We have to prove this function is neither strictly increasing nor strictly decreasing on the interval 1 minus 1, 1. First of all, let's differentiate. F dash of x is 2x minus 1. Okay. So to find the x values, we'll equate to 0. So 2x minus 1 equal to 0. We get 2x equal to 1. So x is equal to 1 by 2. So the intervals minus infinity, infinity, and they have given the interval minus 1, 1, isn't it? Within that we get this 1 by 2. So we get minus 1, 1 by 2 and 1 by 2, 1. These are the two intervals. Okay. So when x belongs to the interval minus 1, 1 by 2, the values f dash of x is 2x minus 1. The values are negative. And here, if you check, this will be negative minus negative. We get the negative sign. That is, f dash of x is less than 0. So the function is strictly decreasing on this interval minus 1, 1 by 2. So when we take the next interval 1 by 2, 1, the values are positive. So f dash of x is equal to 2 into positive. So definitely this will be the greater number, isn't it? So greater number is positive, smaller number is negative. We get the positive sign. That is greater than 0. That is strictly increasing. So for this we get strictly decreasing, and here it is strictly increasing. So within this minus 1 to 1, we have both increasing and decreasing. We cannot conclude anything. So the function is neither increasing nor decreasing on this interval minus 1, 1. Question number 13, on which of the following intervals is a function given by f of x is equal to x power 100 plus sin x minus 1 is strictly decreasing. So the derivative is f dash of x is 100 x power 99 plus cos x. Okay. For the interval x belongs to 0, 1, that is option A. All the x values are positive. So positive, and x is also, cos x also, here we get positive. So the function is strictly increasing. And when x belongs to the interval pi by 2, pi, that is from 90 to 180, cos x is decreasing. But if you check here, cos x values are from the range minus 1 to 1, that's all. But here we have 100 into. So definitely the greater number is positive, smaller number is negative. We get the derivative as greater than 0 again. So the function is strictly increasing on the interval pi by 2, pi. And when x belongs to the interval 0, pi by 2, anyway the x values are going to be positive, and since it is 0, pi by 2, cos also is positive. So positive plus positive, we get positive value. So the function is strictly increasing. So the correct option is option D, none of these. Question number 14, we have to find the least value of a such that they have given the function x square plus ax plus 1 strictly increasing on the interval 1, 2. As usual, we will find the derivative. We get 2x plus a. So f dash of x is greater than 0 when the interval is in 1, 2. Okay, that is 2x plus a is greater than 0. Since we need to find the a value, we need to find the x value. So 2x is greater than minus a. So x is greater than minus a by 2. When x belongs to the interval 1, 2, okay, the function is strictly increasing. That is, x is greater than minus a by 2. So we get 1 is less than x, less than 2. Okay, and for the least value, we are going to compare these two. Okay, so that is x is minus a by 2 and least value is 1. So minus a equal to 2, a is equal to minus 2. Question number 15. Let I be any interval disjoint from minus 1, 1. Prove that the function f of x is x plus 1 by x is strictly increasing on the interval. Other than this minus 1, 1. We'll find the derivative. We get 1 minus 1 by x square. Here we use u by v method, and when we take the LCM, it is x square minus 1 by x square. That is x plus 1 into x minus 1 by x square. Okay, so when we equate this f dash of x equal to 0, we get x plus 1 into x minus 1 equal to 0. That is x minus 1 equal to 0, x is equal to 1, and x plus 1 equal to 0, x is equal to minus 1. And on the intervals minus infinity comma infinity, we get minus 1 and 1. Okay, so we get the intervals minus infinity comma minus 1, minus 1 comma 1, and 1 comma infinity. Okay, so the disjoints other than this minus 1 and 1 is minus infinity comma minus 1 and 1 comma infinity. So when x belongs to the interval minus infinity comma minus 1, the simplified form is x plus 1 into x minus 1 by x square. Anyway, whatever the x values, the denominator is going to be positive. If you check with the numerator, both will get the negative value. Yeah, so negative into negative, positive by positive, we get positive. It is greater than 0, the function is strictly increasing. And when x belongs to the interval 1 comma infinity, all the x values are greater than 1, that is positive values, so the numerator will be positive. And always the denominator is positive, so we get x plus 1 into x minus 1 by x square, positive by positive, it is positive, greater than 0, the function is strictly increasing. Okay, so the function is increasing on the interval minus infinity comma 1 union 1 comma infinity. Question number 16, the function they have given us log sin x. We need to show that this is strictly increasing on the interval 0 comma pi by 2 and strictly decreasing on the interval pi by 2 comma pi. First of all, let us find the derivative. So log of sin x, so 1 by sin x into derivative of sin x is cos x. So cos by sin it is cot x. Okay. When x belongs to the interval 0 comma 90, tan 0 is 0, tan 90 is infinity. So it is from 0 to infinity. So tan x is positive. Since cot x is reciprocal, that also will be positive. So f dash of x is equal to cot x, we get the positive value. So the function is strictly increasing. When x belongs to the interval pi by 2 comma pi, that is from infinity to tan pi, we'll get as 0. So minus infinity to 0, we get the negative sign. So tan is negative. So since cot x is reciprocal of tan x, we get the cot x also negative. So that is negative, strictly decreasing. Therefore, it is proved. Question number 17, the function log cos x, we need to prove that it is strictly decreasing on the interval 0 comma pi by 2 and increasing on the interval pi by 2 comma pi. So the derivative of log cos x is 1 by cos x for log and it is minus sin x. So it is minus sin by cos, it is tan x. Okay. When x belongs to the interval 0 comma pi by 2, tan is positive but we have negative here. So the derivative is negative, that is less than 0. The function is strictly decreasing. And when x belongs to the interval pi by 2 comma pi, tan is negative and outside we have negative sign, negative into negative it is positive. So it is greater than 0, the function is strictly increasing. If you check both the questions, it will be quite opposite. So question number 18, we have to prove the function x cube minus 3x square plus 3x minus 100 is increasing on the real number. First of all, let us find the derivative. So it is 3x square minus 6x plus 3. To find the x value, we will equate to 0. Since 3 is common, I am taking 3 as out. So it is x square minus 2x plus 1 equal to 0. And taking 3 to the right side, it will be 0. Factorizing this, we get x minus 1 the whole square. Isn't it? Taking 3 to the right side, it will be 0. X minus 1, we get x is equal to plus 1 comma plus 1. So x value will be 1 comma 1. Though the x is positive here, but we have the power 2. Okay, outside we have a positive sign. Whatever the x values, here they have mentioned as real number, whatever it is, when we are squaring it, it will become positive. So we get a positive sign, therefore it is greater than 0, the function is increasing. As it is greater than or equal to 0, we get the function is increasing on the real number. Question number 19, the interval in which y is equal to x square into e power minus x is increasing. As usual, find the derivative. So dy by dx equal to, we will use the product rule. So first we will differentiate x. So it is 2x into e power minus x plus x square into derivative of this will be minus e power minus x. We will take x into e power minus x as common. So we get 2 plus into minus minus x. Okay, so x into e power x into 2 minus x. If we take this, to find the x value, we equate to 0. That is x into e power minus x into 2 minus x equal to 0. So 2 minus x equal to 0, x is equal to 2. And x into e power minus x equal to 0, we will get x as 0. So we get the x value as 0 comma 2. and we plot on the number line, minus infinity comma infinity, it is 0 and 2. We get the interval minus infinity comma 0, 0 comma 2 and 2 comma infinity. When x belongs to the interval minus infinity comma 0, all the values of x are negative. So f dash of x simplified form is x into e power minus x into 2 minus x. Okay, all the x values are negative. And here negative into whatever the exponential value will get negative, and minus into minus positive, so we get the positive value. But anyway, negative into positive, it is negative, it is less than 0, the function is strictly decreasing. When x belongs to the interval 0 comma 2, from here all the x values will be positive. Okay, so f dash of x, the outside x into e power minus x is positive, and if you check 2 minus x, okay, the values for 0 to 2, the values are less than 2. So the greater number is positive, smaller number is negative. So we get a positive. Positive into positive is positive. The derivative is greater than 0. The function is strictly increasing on the interval 0 comma 2. When x belongs to the interval 2 comma infinity, again x values are positive. So f dash of x is equal to the outside value anyway, it's going to be positive. And here the values are greater than 2, as x is negative and 2 is smaller number, x is greater, smaller number minus greater number, it is negative sign, plus into minus, it is minus, so it is less than 0, the function is strictly decreasing. So the option, that is y is equal to x square into e power minus x is increasing, is only on the interval 0 comma 2, that is option D.